All right, it's day 5. It's about 2:21 in the morning. I'm going to continue DSA Prep for my machine learning or a software engineer machine learning interview. Where we last left off was 2 pointers and arrays and string section on this leak code practice. And so now I'm going to continue from this section. Let me pull up my IDE. Oh, I'm not even sharing my screen yet. That's fine. Let me share my screen. Shit, go on my live, Mike.
Are you on YouTube?
Yeah, I'm on
Send the link.
Shit, what's my name on here? I'm gonna just send my name. Okay. So given a sorted array, given 2 sorted integer arrays, array 1 and array 2, return a new array that combines both of them and it's also sorted. So we left off at this question before. Well, we kind of already know how to solve this question. So first thing we do is say class solution. Solution. And we're going to find a thing. We're just going to call it toSort. It's going to take in self. It's going to take an array 1, which is just a list of integers, and array 2, which is just a list of integers, and we want to return a list of integers. So first thing we need to do is initialize our left and right pointer. So we say left right equals 0, and then so because we have 2 arrays and we want to combine those 2 arrays to create a new array, instead of so we want to combine these 2 arrays in ascending order, so from least to greatest, and due to them being sorted, we don't have to sort them. And so what we do is just initialize 2 pointers at the first index of both arrays. And so we say I equals j equals 0. And then we'll say while I is less than the length of array 1. So we're and j is less than the length of array 2. If array 1 I given two sort integer array, real array that combines both of them and is also sorted. So if okay, so the first thing we did is we set our pointers to the first index of both array, or we just initialize the pointers. And so now we're looping through our array 1 and array 2. And so now if the first index in array 1 is less than the first index in array 2, j, then we would say I plus equals 1, and then we would say else or we could just do like this, or we could just say, we can just put it right here and put j. Okay, so else, so if array I is less than array j, then we're going to um, move our I pointer to the right, else then it'll be just j plus equals 1. And so from there, else j plus equals 1. And then while I is less than the length of array 1, okay, so I did forget a step. We want to also have an empty list where we're going to our elements and two. So and then this will be answers that append array 1 I, and then right here we're going to put j, and then while I equals 1, and then we'll have this, And then we'll just do this again, and then we'll just say, while j is less than the length of array 2, j plus equals 1, and then we'll have answer dot append array 2 in j, and then going to return answer. Okay. So looking at the function they call combine, we call it to sort. It takes in two arrays, and then returning it takes in two arrays that are a list of integers, and it returns a list of integers, which is answer. And so we initialize our empty list, and we initialize our I and j pointer at 0. And so now we'll loop through our array 1 and array 2, and we say, well, I is less than the length of array 1 and j is less than the length of array 2. If array 1i is less than array 2j, then we'll pin the index of then we'll pin that element that's at that index, and then we'll move to the right. Else we'll do the same thing for array 2. And now we want to iterate through or loop through our array 1 again and 2 again for these steps. And then we'll just say while the length of array, or while I is less than the length of array 1, then we'll pin those elements to our list. And we'll do the same thing for j as well. And then we'll just return the list. Like in the previous two examples, this algorithm has a time complexity of O(n). It uses O in space with 2 pointers. If we don't count the output as extra space, which we usually don't. For example 4, 329 is subsequence given two strings s and t. So class solution will define a function called subsequence, which is going to take in itself. It's going to take in s, which is a string. I'll take in t, which is a string, and then we're going to return a boolean. And the first thing we want to do, it says given two strings s and t, return true if s is a subsequence of t or false otherwise. A subsequence is a sequence of characters that can be obtained by deleting some or none of the characters from the original string, or maintain the relative order of the remaining characters. For example, ACE is a subsequence of ABCDE, while ACE is not. In this problem, we need to check if the characters of S appear in the same order in T with the gaps allowed. For example, ACE is is a subsequence of ABCDE because ABCDE contains the letter ACE in the same order. The fact that they aren't consecutive doesn't matter. We can use 2 pointers to solve this in linear time. If we find that S of I T that we found position, so we can move on to the next one by increment I. We should just increment J. Okay, so let's solve this. Um, let's try to solve this without looking at the actual solution first. So, given two strings S and T, return true if S is a subsequence of T or false. And so we'll just do the same thing. So we want to return true if S is subsequence or not. So we don't need an empty list. We can just set up pointers. We can say I equals J equals 0. And then we'll say while I is less than the length of S and T is less or yep, and J is less than the length of T. So return true. So given two strings S and T, return true if S is a subsequence of T or false otherwise. A subsequence of a string is a sequence of characters that can be attained by deleting some or none of the characters from the original string while maintaining the relative order of the remaining strings. For example, ACE is a subsequence of A, B, C, D, E, or AC. Okay. So if we want to handle the edge case, the first thing I'm thinking is right now if S of I is not equal to J of T or T of J, return false. And then or yeah, so let's just write that down. So if S of I is not equal to T of J, return false. A subsequence of a string is a sequence of characters that can be attained by deleting some of the characters from the original string while maintaining the order of the remaining characters. For example, ACE is a subsequence of A, B, C, D, E, while ACE is not. In this problem, we need to check if the characters of S. Actually, okay. In the same order with gaps allowed, for example, because we can use 2 pointers to solve this in linear time. If we find that S of I equals T of J, that means we found the letters at position I and S. They can move on to the next one by incrementing. So if uh, that'll be I plus equals 1. And then this would just be J plus equals 1. We should increment J at each iteration no matter what, which means we could also implement this algorithm using a for loop. Okay. S is a subsequence. Now, let me just read it. Okay, so I wasn't too far off. Okay, that's not bad, actually. That's actually amazing. So, yeah. And we want to return a boolean. So, yeah, that makes... And then we want to just return I minus the length of S, or I pretty much just saying is if I equals the length of S, then we return true. So, okay. We're just gonna redo the problem again. Given two strings S and T, return true if S is a subsequence of T, or false otherwise. A subsequence of a string is a sequence of characters that can be obtained by deleting some or none of the characters from the original string while maintaining the relative order of the remaining strings, remaining characters. For example, ACE is a subsequence of A, B, C, D, E, while ACE is not. So we say class solution, and then we define a function. We just call it subsequence sequence, and then it's going to take in itself. It's going to take in S, which is a string. It's going to take in T, which is a string, and then we just want to return a bool. And so we're going to initialize our pointers at the first index of each array. And so we'll say j equals 0. And now we're going to iterate our loop through our arrays. And so we'll say, well, I is less than the length of string or S, and j is less than the length of T. if si equals t of j, I plus equals 1, I guess this would just be an else, and then it'll be just j plus equals 1, or, and then from here we'll just return I minus the length of s. And so what we're doing right here is initializing our I and j pointers at the first index of s and t. We want check and make sure that our so what we have is two strings, and these two strings we want to find it if t or s is a subsequence of, or if t is a subsequence of s. And so in order to do that, we need to check each element in each string, pointer by pointer. And so what we would do is initialize two pointers, I and j, at the first index of our arrays. And so we'll loop through those. We'll loop through the length of our arrays and set our pointers to the first index. And if string s and string t equals each other, then, or let me not say that. If the first elements in string s and string t are the same, then we'll move our I pointer to the right. Else, we'll move our j pointer to the right. And then once that's been exhausted, we'll just return I minus the length of s, and that should return true, and that's a true statement. And so again, we have two strings. We're initializing our pointers at the first index of those strings. We're looping through our strings in order to match up the elements in those strings, and we're using pointers at each step to be able to track and match, or to match these elements, and from string t to string s. Okay, and so two pointers uses a big O of n approach with a time or a space complexity of O of 1, which is efficient or optimal solution. Instead of doing for loops for both s and t, then matching the elements, the Bruce Force solution or the naive solution would be just to iterate, or to loop through both of the strings, and then match each match each of the elements in the strings to each other until we find our subsequences. And this could be a very daunting task, especially if we have a string with thousands of characters. Um, okay, so closing notes. Remember that what these methods laid out here are just guidelines. For example, in the first method, we started 2 pointers at the first and last index, but sometimes you might find a problem that involves starting a pointer at different indices. In the second method, we move 2 pointers forward along two different inputs. Sometimes there will only be one input array slash string, but we still initialize pointers at the first index and move both of them forward. 2 pointers just refers to using two integer variables to move along some iterables. The strategies we looked at in this article are the most common patterns, but always be on the lookout for a different way to approach a problem. There are even problems that use the 3 pointers. A chapter and article in this course are ordered that I in a way that ideas learned in earlier chapters can be applied to later chapters. 2 pointers certainly has a lot more application than just what's in the article. Don't worry. Before we move to the next part, try the upcoming practice problem. Part we learned. It's weird. Oh shit, it's down here. I'm tripping. Hopefully I don't have the solution already. All right. Okay, write a function that reverses a string. The input string is a given array of characters. S. You must do this by modifying the inputs in place with O of 1 extra memory. So definitely have to use a 2 pointer approach if we want to get uh, optimally get the O of 1 extra memory, or just be simpler just to do that because we'll know we get a O of 1 space complexity, and more than likely we'll get a big O of n time complexity. Let me go charge. Get my charger. Baby, baby, baby. Aaliyah. Trying to find my damn charger. Baby. Aaliyah, you know where my charger is? You took it out. It's on the bed still?
This is Square. Restaurants. This is a free home-sale combo with an extra side of service. Built for fast-paced, growing, I need to streamline my whole operation with restaurants. Square is built for more orders, more openings, more opportunities. For more than 100,000 restaurants nationwide. Square, big in restaurants. Really lemon throw-up leggings and fit to hold you up. Absolutely spring loaded to give you the confidence.
So literally what I'm thinking right now is we can literally start our pointers anywhere. But what we could do is literally we could have one pointer that starts at the end of the list, and essentially we could just move this to the right and and until so literally what I'm thinking is we can, of course, we have a two-pointer approach where we have index at we have a pointer at the first index and the last index of our array. But what if we just had it at the last index of the array, and then instead of using a left and right pointer, we just had one pointer that moved to the right of the array until the whole string was reversed. So that's really where I'm thinking of. But I only kind of know how to do it in the two-pointer approach for now. But literally kind of understanding the problem now. So okay, can we do it this way? Which I'm not sure, but we'll just start the actual problem. We'll solve 1, 2, and then it gets into sliding windows. So we didn't do sliding windows yet. We just finished two pointers. And we do sliding windows. It's 3:05 right now. Bro, I'm not tired. So if in the morning and then do like stacks, queues, and trees, that'd be amazing. But okay, class solution. We have, so we just define a function and let's call it rs, and rs is going to take in self, and s, which is just a list of integers, and we want to return a list of integers. And so we need to initialize our left and right pointer. So we say left, right equals 0, and the length of s minus 1. Need an array. We need an empty array. We put our list in. Oh, we don't need an empty array because we're not actually. So I don't think we actually need the empty list. We can just return the actual. So for now, let's leave that. Or we could just create an empty list and then the output will then we'll just put the reversed so no. So since we want to return a list of integers, we set our answer to an empty list of integers. So we'll say while left is, well, left pointer is less than the right pointer. So while left is less than right, now let's now let's put our pointers. So we'll say if so what are we trying to do? How can we solve this? How can we solve this? Write a function that reverses a string. How can we reverse the string? The input string is given as an array of characters S. We must do this by modifying the input array in place with O1 extra memory. So if S of L so S of L, if it's less than, so if it's less than, if S of L is less than S of R, would it just be L minus equal 1, and then else R plus equal 1, and then what we just return so so if the element and array is less than, And so we have an empty. We want to initialize an empty array because we want to return a list of integers. And so we initialize our left and right pointer, or we set our which is 0, and then why does this shit not stay off? This shit weird. My PS5 be like it'll turn off and then it'll turn back on. So weird. I haven't even touched it. So we initialize our left and right pointers. Now we iterate through our loop, or we loop through one left and right if left is less than right. If SL I think this would probably be R plus 1 and then S minus 1. And then this would just be R and then this would be L. And so if S of L is less than S of R, then R plus equals 1. That's you, Aaliyah? I'm hearing noises and shit. I'm over here tripping out. R plus 1, answer that pin. So if the index, or if the pointer's at the position of the first index and the last, if S of L is less than S of right, then we'll, and then the pin else. Let's just see the solution. Okay. So instead of how I was thinking about it was still, of course, using a two-pointer approach, but moving the elements. For example, that let's say, for example, the last element, which is n minus one, or whatever variable minus one. I was thinking that we could add or increment the positions without making it out of range. So that makes sense. So the best thing would be to swap, because I kept getting out of range as an error when I ran the code. So that should have let me know that we should try a different approach. And so now the approach that we're taking is to swap the elements in their positions to reverse them. So again, since it's 2 points, we initialize it the same. I set it to 0, and then the length of s minus 1, while left is less than right. We say s of left, and then s of right equals s of right, s of left. If, and I remember, then we said let L right equals left or L plus 1, and then R plus 1 or R minus 1. Left to right equals 0, and then the length of S minus 1. Now I'm going to say while left is less than right, S of L, S of right equals S of right, S of left, and then we just say S of left or left, right equals plus 1 R minus 1. Left, right equals 0. Length of S minus 1, while left is less than right. S of L, S of right equals right, left, left, R equals L plus 1, R minus 1. Okay. Giving an integer is sorted in non-decreasing order. So the sorted return an array of the numbers Given an integer array nums, non-decreasing order. Okay. Right equals 0. The length of nums minus 1. So I'm not sure about this, and I'm not going to try. I'm just look at the solution so I can keep going. So immediately what they did is say they initialize the left and right pointer. So we have 0 and then the length of nums minus 1. We set our result equal to I wasn't paying attention at all. So let me pay attention. Actually, I'm not even going to look at the video. I'm just going to keep writing it down until I get it. So we initialize our pointers, and then we have a result. So right now I'm thinking about how do I necessarily write this down in a way that I can understand it. So I understand everything from here. But it's actually up here where I'm confused because I should be able to just to set this to result, but n, they have the length of nums equals to n, and so our result will be this makes sense to me. Okay, so the first thing we're going to do is initialize our variables. So we already initialize our left and right pointer. We need to now initialize the result. Length of nums. So we want to wow left is less than right. All right, so no, it's not. And I know it's not because I just seen it. We need to iterate over the list and reverse. Start a loop that iterates over the indices and nubs. And reverse order for the last index to first index. Okay, so for I in range, the length of nums, -1, -1, -1. Check if the absolute value of the element at the index left is greater. That's very. It's greater than the absolute value of the right. Square the value at index left and assign it to current index I. Otherwise, square the value at index right and assign it to the current index I. So if the absolute of nums left and absolute nums right so I equals nums left squared left plus equals 1 else as I equals nums right squared right plus equals 1. And then return res. All right. So first thing I'm gonna do is initialize the pointers, left and right pointers. So 0, the length of nums -1, and then when I set a result, you can hear so list of zeros minus the length of nums for times the length of nums, and so for I in range for I in range -1, -1, -1, and we're going to reverse it. say if the absolute gotta remember we're scoring. I'm tired. Let's keep going. So wait, it's not important. It's minus 1. And then we want to set a result equals to minus the length of nums or times the length of nums times the length of nums times the length of nums for I in range length nums -1 -1 -1. It's actually going to nums L is greater than the absolute value of nums, right? Whereas I equals nums squared. equals nums r, and then return res. So left, right equals 0, length of nums minus 1, res equals time length of nums, and we want to say for I in range length of nums is 1, -1, -1, and then if absolute value of nums greater than the absolute value of nums, right? Res of I equals nums left squared left plus equal 1 else left right pointer 0 length nums minus 1, and then we say res equals 0 times the length of nums for I in range length nums if absolute value nums L is greater than absolute nums, right? Res I equals nums of left, nums of left, nums of left 2 else, and then L plus equals 1 else R, and then R is equal 1, and then we just return res. Going for about an hour and 30 minutes. Hour and 38 minutes. Okay. Like two pointer sliding windows works. Actually, let me do this.
Read aloud is a Chrome and Firefox extension.
Read aloud is a Chrome and Firefox extension that
Read aloud is a
Read Aloud is a Chrome and Firefox extension that uses text-to-speech technology to convert web page text to Before we start the course, let's talk about some basics that you'll need.
Yeah, I'm gonna call it a night or a morning. I'm gonna be up in the morning. I'm probably gonna wake up around somewhere like 7:30, 8 o'clock. Probably hit the ground running. Probably anywhere between 11 to 12 to 1, sometime around then. And then we're gonna probably get another 3 to 4 hours in tomorrow as well. And then on the weekend we're gonna try to do anywhere between 6 to 8 hours. We have to, we have to. Um, and then I have some technical prep with my friend Nana. We're going to do that tomorrow, Saturday, and Sunday. And yeah, the grind don't stop. When I get up in the morning, I'll be back on.